out today, obviously, and we're going to talk a little bit more about continuity. And so tomorrow when we come in class, you will work some more with continuity and discontinuous functions. And then on Thursday in class, you will have your learning target over continuity. So remember that in order for something to be continuous, the limit, the left-hand limit of your function has to equal the right-hand limit of your function as x approaches a from the right, which has to equal the plane limit, which has to equal the function value at that particular spot, at the value of a, I should say. So in order for us to determine whether something is continuous or not, we first always have to identify the left-hand limit and the right-hand limit. So when I am looking at my first question here, in order to determine the right-hand limit or the left-hand limit, I'm going to take this -1 and I'm going to substitute it into that x squared. And so we are going to take the limit as x approaches -1 of f of x is going to equal -1 squared, and that was from the left, -1 squared minus 1. When we evaluate that, we get 1 minus 1, which is 0. So my left-hand limit is equal to 0. Now you need to evaluate the right-hand limit. When I evaluate the right-hand limit, I'm going to take this -1 and I'm going to substitute it into the x value. And so I'm going to say the limit as x approaches -1 from the right of f of x is going to be equal to -1 plus 1, which is equal to 0. And so right now your left-hand limit is equal to your right-hand limit. And remember from last week that if the right-hand limit is equal to the left-hand limit, then that is also equal to the plane limit. We also need to calculate f of 0. And in order for f of 0 to be defined, we have to decide which function not f of 0, f of -1, we have to decide which part of the function -1 is defined in. And so -1 is defined in that particular function. So we know that f of -1 is going to equal -1 squared, which is equal to 0. And so we can say that our function is continuous because we know that the limit from the left is equal to the limit to the right, which is equal to the plane limit, which is equal to the function value at -1. So we're going to write this out so that we have the function f of x is continuous at x equals -1 because the plane limit as x approaches -1 of f of x is equal to f of -1. Okay? So we know that it's continuous at this point. So the next thing we're going to look at is okay, well, what happens if we change and we make one of the inequalities just a less than symbol? Okay? So now we've changed the function a little bit. And now we already know what the left-hand limit and the right-hand limit is because we have not changed the actual values. And so you don't need to do any resubstituting here, but we do know that the left-hand limit, the limit as x approaches -1 from the left of f of x is equal to -1 squared minus 1, which is going to equal 0. We also know the limit as x approaches -1 from the right-hand side of f of x is also equal to 0. And so therefore we do know the limit as x approaches -1 of f of x is going to equal 0. And that's because the left-hand limit is equal to the right-hand limit. So now we're going to evaluate f of -1. In this scenario, f of -1 is equal to undefined because we don't have an inequality symbol that is an equal to there. We just have less than or greater than. So the actual value of f of -1 is going to be undefined. And so my function now is discontinuous. So we can say this time f of x is discontinuous at x equals -1 because the limit as x approaches -1 of f of x does not equal f of -1. Okay, and so if you're kind of thinking about this, since you don't actually have a function value at -1, you definitely have a hole there. And so this actually would give us a removable discontinuity type. It would give us a removable discontinuity in this scenario here for number 2. All right, number 3. So question number 3, we've changed just a little bit here. Notice we've got less than, we have an equals to, and we have a greater than. And so we can say that, and so we can say that the limit as you approach from the left-hand side, we know is equal to 0. We know the limit as you approach from the right-hand side is equal to 0. We also know the plane limit is equal to 0. But what's changed on question number 3 is your function value at -1. And so f of 3 is actually going to be equal to, or I'm sorry, f of -1 is actually going to be equal to +3 here. So I could write out all of these limits again. And so I can say the limit as x approaches -1 from the left of f of x would be equal to 0. The limit as x approaches -1 from the right of f of x is going to be equal to 0. So therefore we know that the plane limit as x approaches -1 of f of x is equal to 0. We also know that the function value of -1 is going to be equal to 3. And that is coming from this middle portion right there on your function. Okay? And so since we know that your function value is not equal to the plane limit, we know that this is going to be discontinuous. But unlike question number 2, I automatically have a function value at -1. And so this is also going to be a removable discontinuity. We just kind of have that. This is called your floating hole scenario here. Okay, so in conclusion, we can say since the limit as x approaches -1 from the left of f of x equals the limit as x approaches -1 from the right of f of x equals the limit as x approaches -1 of f of x does not equal f of -1, the function is discontinuous. Okay, so what you're going to see a mixture of a few things. You're going to see some things from Friday in class on the Delta Math today. And then you're also going to see a couple of these questions asking you whether or not something is continuous or not. I'm going to highly encourage you that if you don't understand some of the questions and you continually get them wrong, to watch some of the videos that are offered to you, and also make sure that you read through their explanations as to why things are wrong. All right. I will see you all tomorrow, and I hope that you have a wonderful day. Bye-bye.